In this episode, we're going to crack passwords, and we're doing it using the John the Ripper tool, which is part of the cryptography module that is a part of the Cybersecurity 101 pathway of TryHackme. And this is the very last room that we had in the cryptography module. We did the basics of cryptography, public key cryptography. We did some hashing in the last episode. And in this episode, we are going to crack some passwords, which is my favorite part of cybersecurity in general. Just you feel like a hacker by the end of this whole thing. So it's a very, very exciting room, very exciting video. What do we got? We got the introduction, obviously. We got some basic terms, setting up the system, cracking some basic hashes. We got Windows authentication hashes, the Etsy shadow hashes, single crack mode, custom rules, cracking password protected zip files, cracking password protected RAR files, and cracking SSH keys, all with John the Ripper. And this is all based on the basics. Like, that's what the crazy thing is about this. Like, this is the basics room and the basics video of John the Ripper, and we're gonna do a lot of cracking of passwords and stuff like that. So it's really exciting. This is like this is the place where you go from theory and you go into practicality, and you start implementing a lot of these commands and a lot of these strategies and tactics that actually make you feel like a freaking hacker. So this is really exciting. Like, when I first got exposed to this, I was stoked about it. I could not get over it. I was on a high for like a week after that. It's such a cool experience. And I think no, this is actually a subscriber only room, so you do need a paid subscription to be able to use it on TryHackme. But if you have John the Ripper on your own Linux machine, or if you just download it, you can then run all of these exercises that we're going to do, and you'll still be able to do all of these things that I'm about to do right now as well. So cool exercise. I'm really excited about it, and we're going to dive into it. If you'd like to support this channel, consider joining Hackaholics Anonymous, which is the premier YouTube community for security professionals and hackers. And we have 4 tiers, which is the Cyber Supporter, Agent, Guardian, and Master. And each tier gets their own Discord server and early access to content. But the Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button, or you can go to youtube.com/@hankhackshackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into John the Ripper. If you have asked around anybody that knows anything or has been long enough inside of cybersecurity and pen testing, they are very familiar with John the Ripper. And this is a well-loved tool. It's very versatile. It can do a lot of things, as you just saw inside of the introduction, the overview. So the prerequisites of everything that we're going to talk about are going to be the previous 3 videos that we did prior to this, which I think episode 21, 22, and 23. And they're all about cryptography and hashing and so on and so forth. And what we're going to do in this video is we're going to crack some Windows authentication hashes. We're going to crack the Etsy shadow hashes, password protected zip files, password protected RAR files, and of course SSH keys. So this room is all about cracking, as you can see right here. So it's really, really exciting. And again, I just keep saying it over and over, but this is literally where you start feeling like you are a hacker, like an actual pen tester and somebody that can do some damage inside of the cybersecurity world. So I'm really excited to go through this with you. I have already started the virtual machine, the attack box, or your own system. If you're doing OpenVPN, if you have the membership to Hackaholics Anonymous, if you have the membership to TryHackme, then you can use the attack box in this particular room, or you can OpenVPN SSH into it and remote login into it and be able to still do all of those things. But for the most part, as long as you have John the Ripper on your machine, you can basically do everything that we're going to be doing. So that's all she wrote. That's all you need for the ability to actually run John the Ripper. To give you a little bit of a review on everything that we talked about in the previous videos, in case you have not seen them yet, hashes. A hash is basically a way of taking a piece of data of any length and representing it in another fixed form. This makes the original value of the data masked, so it basically kind of secures it or disguises it so that you don't know what the actual clear text value was. And the hash value is obtained by running the original data through a hashing algorithm, and it's like MD4, MD5, SHA-1, NTLM, so on and so forth. There's a lot of them. And so we can look at this as a potential example. So if we take the word polo, a string of 4 characters and run it through the MD5 hashing algorithm, we end up with this thing, right? And it's a 32 character MD5 hash. And this does not look anything like the word polo, right? So otherwise, if we take polo mints, which is a string of 9 characters, and run it through the same MD5 hashing algorithm, we'll end up with another 32 character MD5 hash, but it's very different from the first one. That's what hashing does to words. You can get hash values for files and for installation files and so on and so forth. So hashing is applied to a lot of different things. But for words, this is how it works, right? And we did a good example or a series of examples of this in the last video that we did, which was just on hashing. So what makes hashes secure is that they are one way, meaning they cannot be decrypted or reversed. But what you can do is you can compare that hash value. So I can compare it against a massive file that stores all of the hash values for all of the most common words. And then I can just compare the values of those to see if I actually have that hash value in my storage and then what the plaintext version of it is, right? So this is called a rainbow table. Now, the technical explanation of all of this. So it's easy to calculate the hash value of a given input. However, it's a very hard problem to find the original input when you have the hash value. In simple terms, a hard problem quickly becomes computationally infeasible in computer science unless you use computers, the quantum computers, which I think is going to make it a little bit more feasible. So they have to come up with more advanced hashing algorithms. This problem has its roots in mathematics as P versus NP. In computer science, P and NP are two classes of problems that help us understand the efficiency of algorithms. P is for polynomial time. Polynomial, I think that I pronounced that right. Class P covers the problems whose solution can be found in polynomial time. Consider sorting a list in increasing order. The longer the list, the longer it would take to sort. However, the increase in time is not really exponential. Non-deterministic polynomial time are problems in the NP class for which a given solution can be checked quickly, even though finding the solution itself might be hard. In fact, we don't know if there is a fast algorithm to find the solution in the first place, right? While this is a fascinating concept, this proves that fundamental to computing and cryptography. It is entirely outside of the scope of this particular room, but abstractly, the algorithm to hash the value will be P, and it can therefore be calculated reasonably. However, an unhashing algorithm would be NP, which is intractable to solve, meaning that it can't be computed in a reasonable time using standard computers, right? So you can't, all of this to say, when you have a word, you can turn it into a hash value quickly, snap of a finger, blink of an eye. If you have the hash value and you want to get it back into the original word, that's a whole other problem. And depending on whether or not the database that you have actually has that hash value, then most likely you're not going to be able to find it, right? So unless you actually have that hash value stored somewhere, you're not going to be able to find it. To really understand this, I would recommend watching the hashing video that we did right prior to this. So the episode right before this episode was the hashing video. If you haven't seen that episode, I would highly recommend you watch it so you can understand the depths of everything that I just discussed right now. So John the Ripper comes in to help us with this. So even though the algorithm is not feasibly reversible, that doesn't mean that cracking the hash is impossible. If you have the hashed version of a password, for example, and you know the hashing algorithm, you can use that hashing algorithm to hash a large number of words, and we call this a dictionary. And then you can compare the hashes to the one that you're trying to crack to see if they match. And if they do, you know what word corresponds to that hash, and you've actually cracked the hash. This is called a dictionary attack, and John the Ripper, or John, is commonly shortened, which is how we refer to the tool when we go into the command line. This is the tool that conducts the fast brute force attacks on various hashes, and that's basically what we're going to be doing today. So for more in-depth material on encryption and decryption, we recommend Cryptography Basics, which is the earlier episode, and then the Public Key Cryptography, which is another episode, and of course Hashing Basics, which is all of these are basically the 3 episodes that we did right before this video that you're watching right now. So we're going to focus on the most popular extended version of John the Ripper, which is Jumbo John. Look at that. So what is the most popular extended version? It's Jumbo John. That's the answer. So let's actually get into it. To set up your system to actually be able to do the exercises that we're going to talk about today, you need the Jumbo John version of John the Ripper, and then you need the RockU password list. Both of those are free and you can get them fairly easily. If you use the attached virtual machine or attack box that's inside of TryHackme, you don't need to do any of that stuff because it comes with it. But you can also just skip through the installation if you already have this installed on your machine as well. I'm going to quickly walk you through the installation and the version of John the Ripper that is other than Jumbo John. You might not have some of the required tools that we're going to need. So for example, zip to John or rar to John, you need those to be able to run the exercises that we're going to run in this video. So make sure that whatever you do get is actually the Jumbo John version of John the Ripper. And to be able to do that, there's a few different installation instructions that we have here. So on the attack box or Kali Linux, Jumbo John is already installed. So if you actually have Kali Linux installed on your machine, or if that's the machine that you're using and you're not on the attack box that I'm going to be using, then you don't need to because it comes pre-installed on your Kali Linux machine. You don't need to go ahead and install it. And then you can just double check it by typing John into the terminal. So for example, I'm going to actually do it inside of my terminal here to see if this actually exists for me. And I'm going to type John, excuse me, and it says that's my version, right? So it says John the Ripper version, Jumbo, bleeding, whatever. Bleeding, that's hilarious. And then this is basically how it runs. You do John and then give it the options, and then you use some kind of a password file to be able to do it. So I actually do have it installed on my machine, which is great. So if you wanted to install it on some other kind of Linux distribution, you could essentially use the package managers, which is apt, for example, for most of the Ubuntu versions. DNF is the one that is for Fedora. So essentially you're just using sudo and then the name of the package manager, which is apt dnf or yum or whatever it is, and then you would do install and then John, and then it will go ahead and install it. At the time of this writing, these versions provided core functionality and missed some of the tools available through Jumbo John. Consequently, you need to consider building from the source to access all the tools available via Jumbo John, and the official installation guide is available here, which is a GitHub repository, and this is the OpenWall John GitHub repository. So if you go to github.com/openwall/John, you'll be able to get the various installation instructions so that you can get Jumbo John. Installing on Windows, you need to download and install the zipped binary of either 64-bit systems or 32-bit systems, and that I think is also available on the GitHub repository. Oh, it just gave me the install file, but it was something that tried to open it from the GitHub repository. I'm going to cancel it because I do not want that on my Mac OS. It's not a Windows machine, so I hope it didn't even try to download the darn thing. Let me make sure. Yeah, okay, didn't try to download it. Okay, very good. But basically, these links actually get you. So if I copy the link and the address, and if we go to our browser, we can see that this is openwall.com/John/K, John, whatever. So this is actually directly from the OpenWall website where you would get the installation file to be able to get John the Ripper. And then the word list. So there's the SecList repository that's available on GitHub that actually has a copy of RockU in it. So let's see. As mentioned, we have a dictionary attack against hashes. You need a list of words to hash and compare. This is called a word list. There are several different word lists out there. A good collection can be from the SecList repository, which is on GitHub, and you can just Google SecList GitHub, and then you'll be able to find that. There are a few places that you can look for word lists for attacking the system of your choice, and we're going to run through those where we find them. So on Kali Linux and the attack box that we have, it's installed in the user share word list. So if you actually install Kali Linux, you will automatically have a user share word list directory that has the word list that you're looking for. And RockU is the one that specifically we're going to be using for all of the exercises in this video. And this is based on the data breach that happened against the RockU website, and it has over 14 million passwords inside of it. And it's insane to think about, but yes, it does have it. You can get RockU from the SecList repository under that the passwords leaked databases subsection, and then you can extract it from the tar or essentially the zip file, the archive file, using tar and then xvzf RockU So you can unzip it or unarchive it using this command, which is the xvzf. So you're essentially, I forget what the acronyms of those are, but these are the actual, these first three, xvz, are the commands or the options to go ahead and extract something. There we go. X is extract something, and then you have V for verbose, and then Z is the zip file, and then F would be to actually dedicate the file name that you want to unzip using tar, and then followed by that you would give it the name of the actual file that you're trying to unzip, and that's basically it. This is the virtual machine that's been assigned to me for this session, and if you have access to TryHackme as a paid subscriber, you would also get access to your own virtual machine. It's going to be obviously a very different IP address, but that is pretty much it for what we got. So which website breach was the rocku text created from? And that would be rocku.com. So now let's crack some basic hashes. All right, so there are a few different ways that you can use John the Ripper to crack some hashes, hash cracking. The basic syntax is like this. You have John and then the option that you want to use and then the name of the file that you're going to use to crack the name of the dictionary file, the path of the dictionary file, for example. So for example, John, and then you would give it the word list, and then this would be the path to the word list that you're going to use. And then this is the path to the file that you want to crack. So my bad. So this option is actually the option that we have, for example, word list, that we're going to use a word list as our option. And then we would give it the path to the word list. And then we would give it a path to the file that we want to crack. That's basically what it is. So the word list would be one option, right? And it just automatically starts using that word list, and it goes to whatever the file is to try to crack it. If it's a RAR file, if it's just a text file that includes the hash that you want to crack. So for example, this is the actual full command here. The word list equals the path of the rocku word list, and then there's a file called hash2crack.txt, and that's how we run this command for just automatic cracking. If you want to identify the hash, so for example, if you want to know what kind of hash you need to crack, we would use the hash ID Python file, and this is also available through the hash ID repository, and you can just download it by using wget or curl to download the Python file, which is the hashid.py from the GitLab page, and then you can launch it with Python 3 hashid.py because it is a Python file, so you need to launch it as such, and then you would enter the hash that you're actually trying to decipher or trying to identify, right? So first, this is the wget command to actually install it, and then once you have it installed, you would do Python 3 and then hashid, and then you give it the hash that you want to identify. That's basically what we're trying to do. So format specific cracking. So John, and then giving it a format, and then the word list, and then the path to the file. So for example, if you know that it's an raw MD5 hash, that's where the format comes in, and then the word list itself, and then the hash to crack, and that's the command that we would use. And when you tell John to use formats, if you're dealing with a standard hash type, for example, MD5, as in the example above, you have to prefix it with raw dash to tell John that you're just dealing with a standard hash type, though this doesn't always apply. To check if you need to add the prefix or not, you can list all of the formats using John list formats, and either check manually or grep for your hash type using the list formats, and then pipe it into grep to see if it actually exists in there, right? And the -I right here is to be case insensitive, and then the F would, I believe, I don't know, I forget what the F stands for, but I know that -I stands for to be case insensitive, so that you can actually just list through something and then just find it. Now that we know this, we can use these things for the rest of this room that we have. So task 4 is going to be where the files that we're looking for are going to be installed in our virtual machine. And then from there, we're just going to run through everything. What I'm going to do is I'm going to start the attack box so I can actually use it has a nicer interface and there's more functionalities with it instead of just using this thing right here. But everything's actually installed in our task 4, which is the John the Ripper. It's actually on this virtual machine that we see right here. So everything that we want is inside of our virtual machine. I just want to SSH into it. So I'm going to actually start the attack box, and then I'm going to SSH into it, and then we're going to run the exercises. Okay, so I have the attack box up. I'm just going to open up a terminal real quick, and then we're going to SSH into our machine. And it's very simple. You just do SSH and then do user, which is the name of my user. And I'm going to give it the IP address, which is 10.10.121.214. Then we're going to press enter. We're going to say, yes, we want to connect to this, and then TryHackme 123 exclamation. And that's it. So I am now officially logged in to this. Did I log in? Oh, it did. Yes. Okay, very good. We have officially logged in. So there we go. So now we are the user in the virtual machine 121.214. So now we can actually continue with the rest of these exercises, which would require that we actually know what we are doing here. So first, what type of hash is hash 1? What is the hashed or the crack value of this? So let me see if we actually even have the hash ID file. All right, cool. So I do have it. I just basically ran a very simple find command. So find in the root machine, which is what that / represents, something by the name of hashid.py. And then this 2 to the dev null, this portion just gets rid of all of the error messages and only shows you the one successful thing or whatever successful location it is that you're trying to find. So it is actually here. It is inside of the John the Ripper location. So we're just going to go into the John the Ripper, and then where is it? It's in task 4. So we're going to go into task 4, and we should have hash ID Python. There it is. Okay, so very good. So now the first question is, what is the hash of the hash1 text file? So if we go here, we can see that we have hash1, hash2, hash3, and hash4. So I'm going to do Python 3, and I'm going to do hashid.py, and I'm going to do hash1.txt, press enter, and then it says not found, huh? Why is it not found? What do you mean? So should I be giving it the actual hash value? I think that's what I should be doing. That's what's going on. Okay, so we're going to cancel that out. We're going to clear that out. We are going to do a cat of the hash1.txt, and we're going to copy our hash file or hash value, and then I will do one more time Python 3 hashid.py, and then I'm going to give it the hash value. Press enter. There we go. So MD5, 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 MD5. Okay, and the answer is indeed MD5. The next one is, what is the cracked value of hash1.txt? So now we get to use John the Ripper. So I'm going to close this out. I'm going to clear the screen, and then we're going to go over here, and we're going to use a couple of things here. So we're going to first do John. Hopefully you can actually see this. Let me see if I can zoom in a little bit more. So we're going to do John, we're going to do format, and then we're going to do equals raw MD5 or raw dash, come on, MD5. So that's the format. And then we're going to do word list, and that's going to be user share word lists rawq.txt. And then we're going to do hash1.txt, press enter. And there we go. It says, for almost any other reason, biscuit, potentially. I think that's it, right? Session complete. And the cracked value of the hash is indeed biscuit. So very good. We got that right. All right. So what type of hash is now hash 2? So essentially we're going to be running these commands very similarly together. So I don't want to mount anything. I don't know why it's doing that. Okay, so now we're going to look at the hash 2 file. So we're going to do cat hash2.txt, and I'm going to take this, copy that, and then we're going to do Python 3 hash id.py, and then we're going to paste the hash value here, enter, and it is a SHA-1, and I'm guessing it's going to ask us to solve that. So we're going to try to find the value of that. So then we're going to do John, we're going to do format, excuse me, format equals raw dash SHA-1, and then we're going to do word list equals, what was it? User share word lists.rawq.txt, and then we're going to do hash2.txt. There we go. And kangaroo is the answer for that one. So let's see if we got those two. It is SHA-1, yes. The cracked value is kangaroo, yes. So now what type of hash is hash3? And then of course we're gonna find the value of hash3, and then same thing for hash4 and the value of that. So we're going to now try to find all of those other ones. So we're gonna do hash3 and hash4 respectively. So here we go. The clear this bad boy right here. And again, I'm just gonna run the commands and I'm gonna just show you the output. So this one is SHA-256. This is hash3 is SHA-256. And then we're going to now run John. All right, there we go. So microphone is going to be that one. So what do we have? SHA-256 is hash3, yes. And then the value is microphone, yes. Excellent. So far, so good. And now we need to do the same thing for SHA-4. Excuse me, hash4, my bad. So this one says either SHA-512 or Whirlpool are the two potential algorithms that we have for this. So let's see what the answer was. It hash3, hash4 says that it is Whirlpool. So very good. And then so let's go and actually get it. You may have just seen the value of the actual file, but we're just going to run the exercise anyway. So it's going to be John. And then we're going to do format equals Whirlpool. And there we go. Colossal would be the answer. And so we actually were able to pull that up as well. And it is indeed colossal. So pretty simple, right? Pretty simple series of commands that we were able to run to actually be able to get all of this stuff. Number one, we needed to actually get the value that is inside of the hash file. So hash4.txt, you do a cat, which it basically concatenates, meaning it displays the contents of that text file onto our screen for us. And then we're going to copy this whole thing. And then that ends up being our hash value that we're going to feed into hash ID's Python. And then we're going to just paste that. And when you press enter, it says these are the possible hashes. And it says least possible hashes, which is SHA-12, SHA-512, and then Whirlpool, and then it's HMAC, and that's the only thing, because the possible ones are still 512 and Whirlpool, it just doesn't have the HMAC at the end of it. And then so you do Control-C, and you get out of that, and then just you run the command, the John the Ripper command, using the format, which is Whirlpool, and then we use a word list, which ends up being the same path, right? So user share word lists rawq.txt, and then we say hash4.txt, and then it runs it. And what did I do? Whirlpool, John, format, Whirlpool, word list, user share word list rawq, hash4.txt. So it says default input encoding 1password hash, cracked 1password hash, use show no password hashes left to crack. So it did crack it, but it's just not showing it to me. That's so weird. I wonder if it's because I already cracked it once. So let's do show at the end of that. And it says invalid options show. That's so weird. I literally just did this. So it's like, why isn't it working? Oh, you know what? I think maybe it's because I didn't do raw Whirlpool. Maybe that's what it is. So let's try that. And then we'll do raw Whirlpool. Whirlpool. I spelled Whirlpool right. So I don't know if that's the reason why. There is no such thing as raw Whirlpool. So maybe I'm misspelling Whirlpool or something. Whirlpool. No, that's so weird. I literally just did it. You saw me do it. So this is the thing that I'm like, what the heck? Why isn't it working? I literally just did this. And it's now telling me that I can't do it. That's so obnoxious, dude. Okay, so this is what I find to be very interesting. So it did solve it. and it said that it's been saved inside of this file right here. So I basically just concatenated that. I displayed it onto my screen. I did cat, and then I did the path to that file. And it has all the ones that it's solved for us so far. So it has biscuit, kangaroo, microphone, and then the whirlpool hash, which is colossal. So it does have it. I don't know why it didn't display it onto the screen for me, which is very interesting. I think it's because the first time that you do it, it displays it onto the screen. The next time that you do it, it just says it's already been cracked, and just check the file that stores all of that stuff. So in either case, we have all of our answers, and now we can move on to cracking Windows authentication hashes. Authentication hashes are the hashed versions of passwords that are stored by an operating system. It's possible sometimes to crack them using our brute force methods, which is basically what we've been doing. To get your hands on these, you have to first be a privileged user more often than not. So we'll explain some of the hashes that we plan on cracking as we actually attempt them. So the first one is the NTLM, also known as the NT hash. The NT hash is the format for modern Windows operating system machines that are used to store user and service passwords. It's also commonly referred to as NTLM, which references the previous version of Windows format for the hashing passwords known as LM. Thus, we have NTLM. So a bit of history, the designation for Windows products originally meant new technology, that's what NT is. It was used starting Windows NT to denote products that are not built from MS-DOS operating system. Eventually, the NT line became the standard operating system type to be released by Microsoft, and the name was dropped, but it still lives on in the names of some Microsoft technologies. And then the SAM, which is the Security Account Manager, is used to store the account information, including usernames and hash passwords. So you can acquire the NT hash or NTLM hashes by dumping the SAM database on a Windows machine using a tool like Mimikatz, or using the Active Directory database, which is also done ntds.dit. You may not have to crack the hashes to continue privilege escalation, as you can often just conduct a pass the hash attack instead, but sometimes hash cracking is a viable option if there is a weak password policy. So as we established in the last video, to be able to crack a hash, quote unquote, you're essentially comparing it against the database of hashes that has the plain text equivalent stored in the database. You're not actually cracking the hash. You're just comparing it against a very large database of hash values and their plain text equivalent to see if you have it. If you don't have it, then you would just pass the hash and then use that as a login. So now you know this, see if we can use the techniques that we discussed in the last task and the knowledge of what the hash is to crack the ntlm.txt file. This is inside of the basics task 5 portion, and it says, what do we need to set the format flag in order to crack this hash? So let's go and actually run the format, the hash ID option here. So let's see here. We're going to go to task 5 first. And we have the NTLM text file in there. So we're going to do Python. Actually, no, we have to do cat, and then we're going to do ntlm.txt. And that's the contents of it. We're going to copy this, and let's see if hash ID even notices this, because it looks so similar to MD5. So hash id.py, and then we're going to give it the value here, and it says can't open this file, John the Ripper hash ID, no hash file or directory. Oh, I see, because I need to actually look, I need to use the full path of that instead of just the hash ID file. So we're going to do it this way. Okay, there you go. So it did, for the most part, it says that it's MD5, and then you have NTLM at the very, very top right here, least possible hashes, and it says possible hashes MD5, domain cache credentials, and so it is technically NTLM, and that is basically it. So that, I mean, they told us that this was an NTLM hash, so that part is kind of, it's kind of silly for me to run this whole thing. What we need to do is we need to run John, and then we need to do list and then do formats, I believe, and it's going to give us all of the formats that we have over here. And the one that we're looking for is NTLM, and it is, for the most part, I mean, I'm gonna search through this to see if I can find it. Okay, so it just made it a little bit easier for myself. I grepped it. I piped that output, that massive output, into grep, and then I just searched for NT and then made it case insensitive. So we have net NT LM v2, net NT LM. We have NT, we have NT long, plain text, which is another one. So, I mean, for the most part, I think it's either NT long, or net NTLM, or V2. So for searching for NTLM, I mean, the answer that we had over here was NT. That's the actual answer. And then if we went to crack this, we would be able to crack it using a similar command. So I want to see what, see, the hint says it only has 2 characters. So that was how we can kind of establish that it's you know, net NTLM v2 versus net NTLM, or net NT, or NT long, so on and so forth. All right, so now that we know the format, we're just basically gonna run it. So John format equals NT, and then we're gonna do the same thing. Word list equals user share word lists, and then rocku.txt, and then the hash file, which is ntlm.txt. And it's going to run, and then the value is mushroom. And what do we have over here? Mushroom. Nicely done, right? Not too complicated. It's fairly simple. Once you have the format down and you know how to find the algorithm, it's fairly simple. The Etsy shadow file was another file that we talked about in the hashing video, the last hashing video. And it stores all of the hash values of the user's passwords on a Linux machine. And for the most part, it is not accessible to anybody other than a root user or a sudoer. So what we can do is we can technically unshadow the files. But in order to do that, we need to combine the Etsy shadow file with the Etsy password file. The Etsy password file is publicly viewable, so everybody can actually view it. But it only shows the list of the usernames. It does not show the hash values for their passwords. The Etsy shadow file is the only file that actually has the hash values for the passwords. So in order to be able to do this, we're going to use a tool that is built into John called unshadow. And the basic syntax is unshadow, path to the password file, and then path to the shadow file. And you need both of those files. And so you would unshadow, and then you would run essentially the full path, which is Etsy password and Etsy shadow. And that's basically it. So unshadow, local password, local shadow, and then it goes into the unshadowed.txt. So you do need to actually output it into a new text file, which will end up storing the combined version or the unshadowed version of the file. You can either use the entire Etsy password, Etsy shadow file, assuming you have them available, or you can use the relevant line for each example. So file 1 would be the local password file, which is the Etsy password file. And then the line for the user would be this guy right here. The line for the root user is the very first line. File 2, the local shadow file, contains this. And then the line for that would be this whole thing right here. And then you would combine them together. Now, this is actually showing the contents of the shadow file. This is the hash and everything that we discussed in the last video. So this is assuming that you actually can read the shadow file, right? So we can then feed from the output from the shadow file. So we can feed the output of the unshadow file into our example, which is the unshadowed txt, and then directly fed it into John. So it would still use the rocku word list, and the format would still be the same, but then you're just going to look at the unshadowed text file. And so now that we can do this, it says if you can follow the process to crack the password hash of the root user provided in the Etsy hashes file, good luck. These files are located in this particular location. So I feel like it is already available to us. So let's see if we can go into task 6 and find it. Yeah, I mean, so inside of the task 6 directory, we have the local password and local shadow, and it's been turned into the Etsy hashes txt file. So if I wonder if I just run this, if it'll actually work. So SHA-512 is what it said, or let's do raw SHA-512, and then we're going to do the word list. Okay, that is my bad. The Etsy hashes file is not the unshadowed version of this. It's saying this is everything I managed to recover from the target machine, da 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 da. And then they gave us the local password and the local shadow, which actually contains these two values that we see right here. So we actually have to use the unshadow command first. That actually makes sense because they want us to practice. So we are going to first do the unshadow thing, and then from there we're going to crack the hash. Okay, so there we go. We ran unshadow, local password, local shadow, and then we outputted it into the unshadowed file. And now we have that, and it is a 512 crypt from what the hint kind of in the task actually gave us. So now I'm just going to use John. Format is going to be SHA 512 crypt, and then I'm going to do the word list, and everything else is going to stay the same. Okay, so there we go. So we actually have the 1Password hash that's actually been done, and it's inside of our file. So home, let's see if we can find it. And there we go. So this is the one right here, and it says 1234 is the password, which is actually the answer that we're looking for here, which is 1234. So that did work. My apologies. I kind of assumed that it was already done for us, but I didn't read the file that was like you know, Etsy shadows or whatever, and I didn't realize that there was this whole note that somebody had left in there. I thought it was already the completed unshadowed file for us, and it was not. So now we have the way that we were able to get that, and we unshadowed it, and then we cracked it, and that was it. So now let us run the next exercise, which is single crack mode. So single crack mode, as the name implies, John uses only the information that was provided in the username to try to work out the possible passwords heuristically by slightly changing the letters and numbers contained within the username. So for example, it's called word mangling. And we can mangle the word. So for example, the username Marcus, some possible passwords would be Marcus1, Marcus2, Marcus3, or Marcus with a capital A, AR, or ARK, and then Marcus with an exclamation, a $sign, so on and so forth. So these are ways to create passwords from the username Marcus by using the word mangling technique. This is building its dictionary based on the information it has been fed, and then uses a set of rules called the mangling rules, which define how it can mutate the word that it started with to generate a word list based on relevant factors for the target that you're trying to crack. And this exploits how poor passwords can be based on information about the username or the service that they're logging into. Geckos is another way. So word mangling also features compatibility with Gecko's field of Unix operating system, as well as other Unix-like operation systems like the Linux operating system. And then we have Geckos, which is the standard for General Electric Comprehensive Operating System. And we looked at the entries for Etsy Shadow and Etsy Password in the last task. So you'll notice that the fields are separated by a colon. The fifth field in the user account record is the Geckos field, and it stores general information about the user, like the user's full name, their office number, and telephone number, among other things. John can take information stored in those records, such as the full name and home directory name, to add to the word list it generates when it's cracking the Etsy Shadow hashes with single crack mode. And then using it would be done by doing single instead of the word list, right? So it says we just want to do this in single hash cracking mode. We give it the format, and then we give it the path to the hash file or the hashes file, and then it'll try to generate it for us. So it'll go from this right here. So if you're cracking it in single hash mode, you need to change the file format that you're feeding John for it to understand what data to create from a word list. You do this by prepending the hashes with the username that the hash belongs to. So according to the above example, we would change this file into Mike, and then that would be the hash value that follows it, and then it would know what it's doing, basically. So what we're trying to do now is we're trying to take the Joker's username, and then we're going to try and crack his hash by prepending the hash value. So first I'm going to go into the task 7 file, and inside of that folder we actually have the hash 07 file, and it has the actual hash right here. So what I'm going to do is I'm going to copy this, and then I'm going to essentially just create a new one. So we will do echo, and then we'll do Joker, not Josser, Joker, and then we'll place that at the end of it, and then we're going to echo it into the new hash.txt file, and we should have new hash. And if I do a cat of new hash, it should say Joker as well as the hash. So now we have the actual hash value. So we're going to do John, and we're going to do single, and then we're going to give it the format, which I guess, what was the format here? So it gives us the format. Does it give us a format? I guess raw SHA-256 potentially. I'm just going to assume that it's raw SHA-256. If it is, great. If it's not, then I'll run the Python ID, the hash ID thing. So we'll do format equals raw SHA-256. And then from there, we will give it the new hash.txt and let it run. There is nothing as raw SHA. Oh, it's not SHA with a W. Bro, what are you doing? Like, what are you doing? There we go. And it says no password hash is loaded. Isn't that interesting? I did have new hash.txt, so what am I missing here? So let's see. We have the hash. We added the user to it. And then format, single, John, hashes. For the most part, I think I did it right. So now that we're familiar with this, single crack, access the hash and crack it, assuming that the user belongs to his Joker. The file is located in that location. And so the user is Joker. That's the hash that we have. It would be new hash would be the name of the file. And new hash.txt is what I did. So I wonder what the issue is. Okay, well, that seems to have been the issue. It was the wrong format. So it's MD5. So it would be raw-MD5 would be the way that we would need to run it. So now I will try that one more time. I'm going to go back into the task 7 location, and we have the new hash. So now we're going to do MD5. So we'll do single, and then we'll do format is going to be raw MD5 like that. And then we have new hash because we don't need a text file. And there we go. Okay, so cool. So Joker is the password with a 3 instead of an E. And that is indeed the password here. So I was just using the wrong formatting, and I needed to identify the format of the hash value that we were trying to dehash or decrypt or whatever. And that's it. So now we can go and look at custom rules here. So just like the single crack mode and the other rules or formats that it actually has, or the methods or mediums that John can work, we can actually create our own custom rules. Many organizations require a level of password complexity to try to combat dictionary attacks. In other words, when creating a new account or changing your password, if you attempt a password like polo password, it'll most likely not work, and you'll actually be notified that it's a weak password. So the reason would be the enforced password complexity. As a result, you may receive a prompt telling you that passwords have to have lowercase, uppercase, number, and a symbol, which is complexity. However, we can exploit the fact that most users will be predictable in the location of these symbols. So for example, the uppercase would be the first letter, and then the number and the symbol would be at the end of it typically. So for this criteria, many users will turn polo password into this, right? So considering the password with a capital letter first and a number followed by a symbol at the end, this familiar pattern of the password appended and prepended by modifiers like the capital letters or symbols is a memorable pattern that people use and reuse when creating passwords. This pattern can let us exploit password complexity predictability. So this meets the password complexity requirements, meaning this thing. However, as attackers, we can exploit the fact that people know the likely position of these added elements to create dynamic passwords from our word list. We know that people will actually do this, right? So how to create the rule would be done inside of the configuration file for John, which is inside of the optional installations. So opt John and then John configuration on the attack box that we have, but it's usually, if you can find where John was installed, or if you've dedicated where it should be installed, and in Linux, it's typically inside of the optional installs. I would be inside of the John directory, and it's called John conf, or if you don't know where it is, for example, and you want to find where it is, you can run the same command that I ran earlier, where it's basically you do find and then you give it the / to look inside of the entire computer, and you say by the name and you want john.conf to be found, and then we would do to dev null to just get rid of all of the error messages, and immediately it shows you where it is. So you have opt, and then you have the other one which is for the specific user, and then the etc directory as well that has a configuration file. And I think it's the same, but I think when John uses its configuration file, it's typically referring to the opt directory of it. So if you, it's located here, if you have it installed using a package builder or from the source with make, so that's where it would be typically located. So let's go over the syntax of these custom rules using the example that we have, and defining a massive or granular, massive level of granular control in these rules. So if you look at the wiki page that they have for John, which is on OpenWall's website, it will show you the configurations and the character classes, the string commands, all of these other things that would be good to know for using John. So now, the first line is list.rules, and then thm rules is used to define the name of your rule. This is what you will use to call your custom rule in a John argument. So for example, we use a regex style pattern, which to match the pattern match to define where the word will be modified. I just lost my mind. Again, we will only cover the primary and most common modifiers here, which is AZ takes the word and appends it with the characters that you define. A0 takes the word and prepends it with the character you define, and then C capitalizes the character positionally. So these can be used in combination to define where and what in the word you want to modify. We must define what characters should be appended, prepended, or otherwise included. We do this by adding character sets in square brackets where they should be placed. These modifiers follow the modifier patterns inside the double quotes, and here are some common examples. Please note that the -a will include only a, and -this will include the symbols and at, so on and so forth. So this is what it kind of looks like. So if you want to do A to Z, it's going to include both upper and lowercase letters. A to Z is going to include only uppercase letters. A to Z is going to include only lowercase letters. So you can see like this, the first one is uppercase, the second one is lowercase. That means it's going to be both upper and lowercase. This is all uppercase, this is all lowercase. And then this is only going to include the number 0. 0 to 9 would include 0s to 9, so on and so forth. So putting this all together to generate a word list from the rules that would match the example password polo password 1, assuming the password was polo password in our word list, we would create a rule entry that looks like this. So the list rules polo password, this would be the name of the rule. And then this is what the regular expression essentially looks like. So C would be for capitalizing the character positionally. So you would put it in front of the very first letter. And then you say AZ, and then you have inside of the quotations the rest of your pattern. So this C capitalizes this first letter, AZ appends to the end of the word, so this appends to the end of the word, and then 0 to 9 is a number in the range 0 to 9, and then these are the passwords followed to the symbol. So you have, this is the actual rule, so you capitalize the first letter, that's the rule, and then at the end of the word, the password itself, you want to append these things, right? So that's what this piece follows. The very first thing is just say capitalize the first letter. This would be appended to the end of the word, and then these are the things that I want you to append. A number in the range of 0 to 9, a password that has any of these symbols. So rule polo password is the rule that we would actually use, and then it would be John word list path to the actual word list, rule polo password, and then path to the file that we want to crack. As a note, it says, I find it helpful to talk out the patterns if you're writing a rule as shown above the sample. The same applies to writing regex pattern. Jumbo John already has an extensive list of custom rules containing modifiers for almost all cases. If you get stuck, try looking at those rules, which is around line 678 if your syntax isn't working correctly. Now it's time to go. So what do custom rules allow us to exploit, which is the password complexity predictability? That's what custom rules allow us to exploit. what rule would we use to add all capital letters to the end of the word? So if we go over here again, just to kind of see what we're trying to do, we're trying to see all capital letters. So it's A to Z, both caps, right? And then it's not inside of the square brackets. And we're trying to put it to the end of the word. So it's A0. And then you would put inside of the quotes A to Z. So that should be what the answer is right here. Yeah, so all capital letters to the end of the word. It should have been A0, not AZ. That's actually very interesting. So to the end of the word, let me go double check this right here. Takes the word and appends it with the character, appends it. I see. A0 prepends it, my bad. A0 prepends it, AZ appends it. Very good. Append meaning it adds it to the end. Everything else was right though. Okay, so cool, there's that. And what flag would we use to call a custom rule called THM rules? It would be the dash, where is it? Dash rule, and then THM rule would be the flag that we would use. And there it is. That's it. So I'm not going to create one because it would take time and energy and effort, but essentially it would be exactly the same thing here. I don't want to be lazy. I'm not trying to be lazy. The instructions have been very clear for us, so we can kind of use the instructions and some of the questions that they asked us. I don't want to go down that rabbit hole because I am limited on recording time this evening, but I promise you, if you follow the rules and all of the instructions that was here, you will not have an issue. And then if all else fails, you can go to Gemini and ask it a specific question about what you're trying to do, and it'll help you. But for the most part, if you actually follow these instructions, I promise you it'll work. So let's move to the task 9, which is cracking passwords, password protected zip files. So this is one of those things that, again, it kind of comes down to the complexity of the password that was used to lock the zip file, right? Because in a lot of cases, if you're getting a zip file from an insurance company or something, they're not going to give you like a simple password. It's usually a very complex password. So just keep that part in mind. Very similar to the unshadow tool that we used previously, zip2john is another one of those tools that comes with Jumbo John. And it's like this. So zip2john, and then the options, the zip file, and then the output file would be the unlocked version of the file. So the option would be to pass specific checksum options to this. It's typically not necessary. The zip file is the path to the actual zip file, and then this redirects it, and then the output file is the file that would be unlocked. So zip2john, zip file, and then zip hash. That's basically it, right? So then when we're then able to take the file that we output from zip2john, in our example, the hash, and then as we did with unshadow, and then feed it directly into John as we have made the input specifically for it. So my bad, this is not the unzipped file or the unlocked file, it's the hash value of the locked file, so that we can go ahead and crack it. So now we have a zip file that is inside of task 9 that we're going to go ahead and do this with. So let me clear the screen. I'm going to go into task 09 here, and we're going to list it, and it says there's a secure zip file. So it is zip2john, and then I'm going to do secure.zip, and then I'm going to do zip hash.txt, and we'll do that. And let me see if I got it, and I did get it. So there we go. So it did actually work. Zip2john, secure zip, and then that forward button, and then zip hash.txt, and now I have a hash value here. And if I most likely have to run the hash ID thing. So let's do zip hash.txt real quick. Zip, my God, I can't even spell. See, that's what happens at the end of the night. This is massive. Look at this thing. This is a large freaking file here. So cat of zip hash.txt looks like this, and flag.txt, pkzip, so on and so forth. So all they did was they just used the zip hash file without any kind of formatting. Feed it directly as we've made the input specifically for it. So I'm just going to run it without looking at the format, because it's very interesting. So we'll run it, see if it actually works, because that's pretty crazy. That's a very crazy output for that. User share word lists, and then we'll do rocku.txt, and then we're going to do the zip hash. Oh, it worked. look at that. That was pretty crazy. So it actually worked. So pass 1, 2, 3. I didn't even need to do anything because it literally analyzed all of this and it was able to pull the hash from it. So now this is the actual password. So now we can unlock the secured file. So we're going to do cat secure, or maybe I can do unzip and then secure.zip. And then it's going to say password. And there we go. And flag.zippy. So there we go. Let's go into zippy. And then there's the flag. So flag. There it is. So that's our flag. THM, well done, hash royal. And there is the actual flag. Cool. So now let's go to hashing password protected RAR archives. And this is also very similar to the zip to John and the unshadow, so on and so forth. So this is called RAR to John. And you can take a RAR archive and then essentially create an output file from it. So RAR to John, and then the path of the RAR file, or the name of the RAR file, and then the output file where we store the output from the command. And so in this particular case, again, it's going to turn it into a hash txt file for us. And then once we want to crack it, we would do it the same exact way that we just did with that zip file hash, and then we would be able to get it. So that's exactly what I'm going to do for the secure RAR, and that's going to be inside task 10. So I will do cd /task10, and we're now inside of, there's no task 10 directory. Oh, I see, because I'm inside zippy. So we will do, there we go. That should be fine. Excellent. So now inside of task 10, we have a secure RAR file. And so what is it called? It's RAR to John, right? Yeah, RAR to John. Okay, so let's run the command for RAR to John, and then we will look at the hash and then dehash the hash, or decode, decrypt the hash. And I think that's basically it for all of our exercises in this video. So let's do it. All right, there we go. So we essentially, I did the same thing. So I did RAR to John, secure RAR. I put it into a RAR hash text file, and then I found it, and then I ran. The first time that I ran it, I forgot to put an equal sign right there. So I just reran it using the word list equals, and then we use RAW-Q, and then the hash text file, and then we got it. So password is the password for that secure RAR. So now we want to look at the zip file. I think, what is it? Unrar. So unrar is the unzip version for RAR files, basically. So we're going to use unrar to unrar it. Ha ha ha. Some of these words are just so fun to say. Like I feel like a kid sometimes. So unrar, what was it? I think it's called secure RAR, right? Yeah, unrar, and then secure.rar. And then what? Did I do this incorrectly? Okay, so I was actually missing the X option, the X flag, to actually extract the file. So we will do unrar X and then secure.rar. And there we go. Enter password. And it is now done. And there it is. Okay, so there we go. Flag.txt. And there's our flag. So that was it for that. And so that should be the flag for that. Excellent. Oh, we have one more, the SSH keys. So let's crack some SSH keys with John. So usually for ID RSA files, there is a SSH private key password. So unless configured otherwise, you authenticate your SSH login using a password. However, you can configure key-based authentication, which lets you use the private key, which is the ID RSA, as an authentication key to log into a remote machine. Doing so will often require a password to access the private key. We will be using John to crack this password to allow authentication over SSH using the key. The tool is called SSH2John, and this is actually a Python file. In our case, it's inside of the opt.john SSH2John location. So if you're doing this on the attack box, you just replace this with Python 3, and then you refer to the Python file. And the sample command is pretty straightforward. So SSH2John, in this case, again, this is being replaced by Python 3, and then the ID RSA file, and then the output file that we want to create. So as an example, this is what it looks like, and then it turns into the hash value. And then when we have that, again, very simple, you just run it and you get the hash value broken down. So this is going to be inside of task 11 for us. and then we're going to get the password for the SSH. So I'm going to clear my screen. I'm going to do cd task 11, and then let's zoom in here. And so inside of this location, we have the ID RSA file. So we'll do Python 3, it should be opt John, and then SSH to John.py. And then we have the ID RSA, and it's going to go into RSA hash.txt. We'll run that, and then there is the RSA hash. So now we can just run John regularly using a word list, and it should be good, right? It should be pretty, hopefully, should be pretty easy to do. And it actually was. And there it is, mango. I love mangoes, absolutely love them. What is the SSH private key password? It is indeed mango, my dear friends. So let's see what our further reading is, and then I'll give you some final summary notes, and we'll call it a night. So the further reading portion of this is basically just telling us to go look at the OpenWall wiki link for John the Ripper, which if you have not checked out, it's a very good resource, especially if you're trying to get really good at John the Ripper, and then use the tool, right? Install the tool, go through as many different versions of exercises as you possibly can, try to crack hashes and create hashes using some of the tools that we went through in the hashing video. I don't think I didn't do it inside of this video, but if you go watch the hashing video, which is the episode right before this one, there's going to be a couple of tools that I show you to create hashes. And then you can obviously also just create hashes using the command line, and there's a lot of different ways to do it. So once you've created the hash, you then want to crack the hash, and then you can do that using all of the exercises that we ran today. So it's a very useful tool. It's one of my favorite tools to use. John the Ripper, Hydra, and these various tools are one of those tools, like Hashcat. These are they kind of are in the same breath when we're talking about cracking passwords and hacking and things like that. If you actually know how to use these things, they're very, very powerful tools. So for the most part, that's basically all I got for you. To get more videos like this one, make sure you like, subscribe, and turn on notification bell. Like, subscribe, and turn on notification bell so that you get notified the next time that a video comes out in the CySec101 playlist. And then there's, of course, a bunch of videos that already exist on the channel, including everything that is available to the Cybersecurity 101 playlist that we have over here. There's, as I'm recording this, there's 27, but I think by the time that you see this video, this will probably be like the 29th video or something like that for that playlist. And then there's a bunch of other playlists and a bunch of other really cool videos that also exist, that they all will serve useful if you know what you're looking for and if you want to do further studies and independent studies, so on and so forth. So make sure you definitely do that, and then drop a comment if you have any specific questions that you want to ask me. I am very responsive in the comment section, and if it's a really good comment, I will create a video in response to your comment. And then if it's really, really good, then I'll create a playlist, which is what we did here in response to Darnell Knight's comment, which is the CySec 101 playlist that we created. So make sure you like, subscribe, turn on the notification bell, and drop a comment if you have any questions, or if you just want to say hi, or if you just want to say thanks. And another way to say thanks would be to support this channel by joining Hackaholics Anonymous, which is the premier YouTube community for security professionals and hackers. We have 4 tiers, which is the supporter, agent, guardian, and master, and each tier gets their own Discord server as well as early access to content. But the agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, and of course much, much more. And you can join by simply clicking the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join to be able to join Hackaholics Anonymous. I hope I see you in those Discord chats. If not, I hope I see you in the comment section of this YouTube channel. And that's it.